Okay, in this video we're going to look at how we can use Karnaugh Maps to help us simplify our Boolean algebra. So we've got our information in a truth table here. It doesn't have to be in a truth table. We can produce our Karnaugh Map straight from some Boolean algebra, and I might show you that at the end. But we're going to transfer our information to this, so it's a Karnaugh Map. So we've got our A and B along the top here, and the C down here. Now it's a special coding sequence. Just have to remember what the coding sequence is. Basically, only one bit changes at one time, but you can just regurgitate it. So in filling out my Karnaugh map, then all I do is look for some easy options. So I've got three zeros here, so I could put my zeros in, and then everything else is going to be a 1, or I can say I could do this row to start with, which is when C is all 0, and then I can do when C is 1, which is all of these, whichever makes it easier. So I'm going to do put in my zeros to start with. So first of all, Q is going to be a 0 when I've got 0, 0, 0. So I've got 0, 0, and a 0. So I'm going to put a 0 in on that one. Okay, and then next time I get a 0 is when A and B are both 0, but C is a 1. So A and B is a 0 and C is a 1. So that will be a 0. And then finally, I get a 0 when A is a 0, but B and C are 1. So C is a 1. Let's scroll along. So here I've got A is a 0, B is a 1. So I'm going to put a 0 in on that one there, like so. Okay, which means then everything else I can then put as 1s. Okay, so I can put 1s in like so, like that. Now the idea with the Karnaugh map is then once we've put all of our 1s in, we want to loop as many of our 1s together in the largest loops possible, and the loops go in powers of 2. The loops go in powers of 2, so you can loop 1 on its own, but if we can loop a 2 together, or we can loop a 4, or even on larger Karnaugh maps we can loop 8s together, so that we've then captured all of our information. Okay. So on this one here, I've got a 1 there, a 1 there, 1 there, and a 1 there. So I can loop that as a 4. Okay. So I've captured all of those 1s there. So I've got this 1 here. Now I could just loop that on its own. Okay. But actually, I want to loop that in the largest size possible in powers of 2. So what I want to do then is I can loop that in with this one here, like so. So I've got 2 loops. And then all you do to produce the Boolean expression is you take each loop in turn. Okay, so there's my Q. Q is going to be 1 when. So let's take this first loop here. Now we're looking for what bits of my expression remain constant. So in that loop there, the C is a 0 or it could be a 1. So we're not interested in the C, but actually, if we then look at the A and the B is a 0, the B is a 1 in that part, but the A is constant, so A is 1. So the only thing in that loop there, is our A. So that loop there stands for the A. So that's that. That's where we get that from. And that's why we loop in the largest size possible, because we eliminate bits that are changing. Okay. So we've then got another loop. So or Q could be a 1 when we've got this loop here. Okay. Now in this loop here, C is constant and it's a low, so I'm going to put that in. So not C. Okay. And what also remains constant this time round is the 1 there for the B. So B is 1 there, but the A changes. So we're going to put that in there like so. So that's that loop there. So that's our simplified expression for that truth table. Okay, so let's do this one. So we'll do exactly the same idea on this one. So I've got 2 zeros in that, so they're going to be my easiest ones to fill in to start with. So we always look for the easiest option so we can eliminate any errors. So a Q will be a 0 when A is a 0. So when A is a 0, but B is a 1 and C is a 0. So I'm going to have a 0 in there. So that 0 in there is that line there. Okay, that line there is that one there. And then also when C is a 1, but A and B are 0, then we'll get a 0 in there. So that's that 0 there, like so. And then the rest of them, because they're the easy ones, we're just going to put 1s in because that's the rest of the truth table. And okay, and then looping round in the largest size possibles. Can you see it? Any largest size possibles? So I'm going to go for a nice loop here of 4 to start with. Okay, and then we've got these ones here. Okay, but we don't want to just loop them on their own because obviously the idea, if we can loop them with something else, then it helps to simplify. So I can loop that there, and I can loop that there. Okay, so we've got 3 loops with this one there. So Q is equal to. So let's take this loop to start with. What remains constant in this loop here? Well, initially there, that C, not C, remains constant. And what else is constant in that loop there is the B remains a 0 between that part and that part. And it's a not B. Okay, so that's that first loop. The second loop should be nice and easy for you because it's similar to that first one. What remains constant? Well, the C doesn't, the B doesn't, and it's the A. Okay, and then finally in this last loop here, what remains constant? Well, C remains constant, and then the B remains constant. Okay. So I just highlight that where I got that from. So that's that from that one, that's from that one, and then that's from that one. And we've helped to simplify our expression down, because otherwise if we're just drawing it out from the truth table, we had 1, 2, 3, 4, 5, 6 parts of the expression. So and that would have been quite challenging to simplify down, but now we've simplified that down. Okie dokie. Okay, so stepping up again now, so we're going to a 4-bit Karnaugh map. So we've got our A, B, C, and D. Don't be put off by this. These can actually be sometimes a lot easier. So if I scan down quickly down my truth table here, Q is high only on 4 occasions. So we can actually, it'd be easier for us to put when Q is high this time round. So Q is high when I've got A is low, B is low, C is low, and D is low. So on here, A is low, B is low, C, D are low. So we've got to have a 1 in there like so. Next time we've got, so let's look at this. So C and D are low, so we're still sticking on this row here. C and D are low, but it's B that's high, so it's going to be a 1 there like so. Okay, and then we've got a 1 here. Let's look at this. I've got C is low, but D is high, so it's this row here. So I always look for the rows that make it easier for me, and then when the rows I look for the columns. So in this case, we're looking at this row, and then A and B are low, so we're going to have a 1 there like so. And finally, looks like we're in the far corner then for this one here. Okay, so it's given us in the far corners. Now you might think, okay, we can't really do a lot with that. Oh, what happened there? Let's just put all of my zeros in so it completes the Karnaugh map. Like so. Now, one of the beauties about Karnaugh Maps is that they wrap around from this side to this side and then top to bottom. Okay, so this one here actually wraps around to this one here, and that one there wraps around to there, but it also wraps around left and right. So what does that mean for us? Well, it's a special one. It is that I can actually wrap it round top and bottom and left and right. So I actually wrap those four ones actually join together like so. So Q is equal to, well, what stays constant in this? Well, the A is a 0 there, and the A is a 0 there for both of these. So we can put not A, and when we look at this row and this row, what remains constant in this row and this row? Well, it's the not C. Okay, and that's our simplified expression for that truth table. And say they sometimes they can look horrible, but actually look at how quick and easy that was. Woo! Okay, for this last example here, I'm just going to take a Boolean expression, and I'm going to do it with a complicated with a 4-bit one. It doesn't make it any more complicated, but just to show you the ease of doing it. Okay, so we're going to do it in steps. So I'm going to take this one here. We've got all 4 bits, and this one all 4 bits identified because it's an individual square. So when A is low, B is low, C is low, and D is low. So A, B, C, D, all of them are low. So we're going to have a 1 just there. Okay, and so that's that one taken care of. I'll just put a line through it just so it highlights. Okay, so now I'm looking for when B is high, but A is low. So I'm looking at that column, but I'm looking also at when C and D are both low. So I'm going to put a 1 in there like so. Okay, right. So that was, it highlights individual squares. Now these two, because the way that they are, they're going to actually highlight multiple squares that are going to be a 1. So let's first of all, let's look at the last bit. So we're looking for the row where C is low, but D is high. C is low, but D is high. C is low, and D is high. So that's that. It's going to be on this row here. And on this row here, we're looking for when B is low. Okay, so let me just say that again. So I've taken, by taking the last bit, so when C is low and D is low, I can highlight that I'm just purely looking at this row here, and on this row here, then by taking that, I'm looking for when B is low. Well, B is low at that point there, and it's also B is low at that point there. Okay, so that's that one done now as well. And then finally, looks like we're on the same row. We're on the same row because we've got C is low but D is high, but we've got this time when B is high. So B is high, and it's going to be high, that one and that one. So what does that simplify down to? We've already seen that we can then loop round the 4 corners together, like so, but we can then also loop all of those together, like so. So taking all 4 corners, because we've already just wrote the answer for that, so we've got our not A and C, and then taking this loop here, well, the AB is going to change. The only thing that stays in that constant in that loop there is the not C and D. Okay, and that's our Karnaugh Maps. Nice and easy.